Okay, so in the last video we discussed about the concept of graph and how this can be used in white box testing. We studied about how nodes and edges can be used to form a graph, and we also studied that there is a possibility that a graph can have multiple initial nodes and multiple final nodes, but a graph must have some initial nodes, one or more initial nodes and one or more final nodes, and at least one node and possibly some edges that connect a set of nodes from one node to another. In today's video, I'm going to describe some other properties and definitions that are going to help us when we apply the concepts of these definitions and in the context of software testing. So today we are going to see what is meant by a path. So path is a sequence of nodes, and you usually enclose that sequence of nodes in these square brackets. So that also means it is possible that a certain node can be repeated in this path that can be duplicated. The square brackets basically represents that it is possible that a duplicate node exists. So when we use the curly braces, as we saw in the last video, when we use to represent this for a set of nodes or a set of initial nodes or a set of final nodes, then basically the curly braces notation is telling us that in such a scenario we don't have duplicate nodes, but in a path we can have some nodes duplicated possibly, and in some cases we might not have any duplicate node. So the number of edges in such a path is going to be the length of the path. So for example, in this case n1 and n2 represent one edge, and then n2 to n3 another edge, and then m minus 1 and nm represents another edge. So we'll count the number of edges that will constitute the length of the path. And if you just have a single node like this, for example, and it just has an incoming arrow, then such a node represents a path of length 0. And what do we mean by a subpath? A subsequence of nodes in P is a subpath of P. For example, P is a sequence of nodes, and we identify certain subsequence in that P that will be a subpath of that particular path P. And we have another definition, reach n, where n is some node, and reach n is a function that will return a subgraph that can be reached from some node n. So for example, in this case we will find out, for example, what is the graph that can be reached from node n. So we will see what sort of edges that go out from node n. This is this node, and then this node, sorry, this edge and this edge and this edge, and likewise we have this edge and this edge and this edge. So all these edges that go out and take us to some other nodes will be the set of nodes and edges, or the sub part of the graph that can be reached from node 1. In the same way, we have definition examples of some paths. Here we have the example that 1, 4, 8 is a path, so that constitutes this path on the graph. In the same way, 2, 5, 9, 6, 2, so that 2, 5, 9, 6 and 2, so this also constitutes a valid path. 3, 7, 10, so this also is a subsequence of nodes or sequence of nodes that constitutes a path on this graph. And if we want to find the lengths of these paths, then 1, 4 and 4, 8, this path has length 2, 2, 5, 5, 9, 9, 6 and 6, 2. This is a path of length 4. And in the same way, 3, 7 and 10, these has two edges, 3 to 7 and 7 to 10. So this path also has length 2. Then we have the concept of test paths and single entry, single exit graphs. So what do we mean by a test path? So this is very relevant in the context of software testing. A path that starts at an initial node and ends at a final node. So what do we mean by that? When we represent a program in the form of a graph, so definitely a program is something with which we need to interact. So the point or the node which represents the entry point of the program is an initial node, and where the program gives us some sort of output is going to be the final node of the program in that graph. So a test path generally is some sort of input given at the entry point of the program, and we want to see what happened in response to that input we gave at the entry point, and that definitely will be seen at the exit point or the output point of the program that will be represented in the form of a final node in the graph. So a test path therefore must be a path that starts at the entry point or the initial node, and it must end at the final node, so that we can see that what happens in response to a certain input which we gave to the program, and what sort of the path it traversed in the graph from the initial node to the final node. So that is further elaborated here, that test paths represent execution of test cases, and it is possible that some test paths can be executed by many tests. For example, yes, it certainly is possible that you can give a certain set of values, certain set of data values to a program that execute certain parts, and it is possible that a certain path can be executed by more than one set of data values. And likewise, there is also a possibility that certain parts in the graph of a program are not executed by any test. So now the next definition is of a SASE graph, and what is meant by that? All test paths start at a single node and end at another node. So SASE stands for single entry and single exit, as stated here. And here is an example of a single entry, single exit graph. Here, this is the initial node number 1, and this bold edged node number 7 is the final node. And here we can see that all paths that initiate at node 1 are all ending at node 7. In the same way, this path 1, 2, 4, 6, 7, another 1, 3, 4, 5, 7, and then another path and 3, 4, 6, 7. All the paths are starting from the initial node and ending at the final node, which is the node number 7. So these paths are representing that they are starting at the initial node and ending at the final node, and these are also examples of test paths. And by definition, a test path starts at an initial node and ends at a final node. Two more definitions are of a visit and a tour. And what do we mean by a visit, and what do we mean by a tour? So when a test path P visits some node in the graph, then we say that N is in P, and in other terms we can say that test path P visits the node N in P. In the same way, if a test path P visits some edge E in the graph, then we say that E is in P and E is visited by this test path. And we just saw on the previous slide that a test path always starts at an initial node of the graph and it ends at a final node of the graph. So all those nodes and all those edges that are present in this test path, we will call those nodes or edges are being visited by this test path. And the next definition is of a tour. And what do we mean by a tour? A test path P tours subpath Q if Q is a subpath of P. So when we talked about nodes and edges, we use the term visit. And when we talk about subpaths, so it means we are talking about paths which are of more than length 1. So in that case, we will use the term tour. So a visit will be about a node or an edge, and a tour will be about some subpath which generally has a length more than 1. So here is an example test path that has nodes 1, 2, 4, 5 and 7. So it means it visited nodes 1, 2, 4, 5 and 7. So these are also mentioned just below the test path. So in the same way, we can identify the edges. These are 1, 2, 2, 4, 4, 5, and 5, 7. These have been visited by this particular test path. And if we talk about tours, then we think about paths that are more than one length 1. So for example, this can be 1 to 4, this can be 2, 4, 5, this can be 4, 5, 7, and 1, 2, 4, 5, and 2, 4, 5, 7, and 1, 2, 4, 5, 7. From where are these coming? These are coming just from this test path. So this is 1, 2, 4, and this is 2, 4, 5, and this is 4, 5, 7, and so on. So in this way, we say that a subpath has been toured by a test path, and a particular node or an edge has been visited by a test path. So that's all for today's video. In the next video, we are going to elaborate some more concepts about the graphs and software testing.